In today's world, technology has advanced so much that even large ships can remain steady in the most extreme weather conditions. But that's not all. Some ships designed by engineers have the ability to return to their original position when overturned by waves. How is this possible? What technology makes ships unsinkable? In this video, we will show you these incredible maritime vehicles that defy the laws of physics. Don't miss this report that will leave you speechless. Have you ever wondered how ships navigate the sea without sinking under the forces and pressures exerted by waves and wind? The stability of ships is the ability to maintain balance when floating in the water, which is crucial to prevent them from sinking due to the effects of waves, wind, or cargo. To achieve this stability, ships have various devices that counteract the swaying motion of the ship, called rolling. In this video, we will show you how these devices work and how they allow large ships, such as freighters weighing hundreds of thousands of tons, to navigate the roughest seas. One of these devices is the bilge keels, which are fixed fins placed on the side of the ship's hull and extend for almost 2/3 of the ship's length. These keels act like wings that generate upward force when the ship tilts, helping it regain its vertical position. The effect of bilge keels is greater the faster the ship goes, making them very useful for ships that sail at high speeds. Another stability device is anti-rolling tanks, which are tanks installed across the width of the ship and filled with water. These tanks serve to balance the weight of the ship when it tilts left or right, causing the water to flow from one side to the other, thereby reducing the rolling motion of the ship and improving the comfort of the crew and passengers. Anti-rolling tanks can be active or passive. Active tanks have a pump system that controls the flow of water in the tanks, adapting to sea conditions and the ship's load. Passive tanks do not have pumps, but have openings that allow water to pass through due to gravity. In addition to the stability system we have shown you, there are other devices that help reduce the rolling or tilting of ships. One of them is the active fin stabilizer, which is a fin-shaped device installed on both sides of the ship's hull and can move in various directions controlled by the ship's sensitive steering system. When the ship rolls or tilts, the sensitive steering system sends a signal to the activation system in the form of electro-hydraulic control. However, active fins are not very effective when the ship travels at speeds below 10 knots or about 18 km/h. In container ships, there is an anti-heeling system, which is a zero control system designed to keep the ship horizontal during loading and unloading in ports. The anti-heeling system cannot be used as a stabilization system at sea and can only be used when the ship is in port loading and unloading containers. Did you know there is a system that prevents ships from tilting and capsizing at sea? This is called the anti-heeling system. The anti-heeling system allows ships to maintain balance when facing external forces that cause them to tilt, such as wind, waves, or cargo. It consists of sensors that detect the angle of heel of the ship and ballast tanks that are filled or emptied of water as needed to compensate for the weight of the ship. The anti-heeling system can be controlled by a main panel that regulates the operation of the anti-heeling pump, or by a startup panel that allows the operator to manually activate or deactivate the system. The anti-heeling system is very important to ensure the safety and comfort of ships, especially rescue ships that perform search and rescue operations at sea. Rescue ships are ships that have the mission of rescuing people and goods in danger at sea, whether due to accidents, shipwrecks, fires, or attacks. Rescue ships must be prepared to face the most adverse conditions at sea, so they have special equipment such as radars, radios, boats, helicopters, stretchers, first aid kits, and extinguishers. Rescue ships must also take into account the ship's balance points, which are the points that determine the ship's stability. These points are the center of gravity, the center of buoyancy, and the metacenter. The center of gravity is the point where the weight of the ship is concentrated. The center of buoyancy is the point where the water thrust force is applied, and the metacenter is the point where the vertical lines passing through the center of gravity and the center of buoyancy intersect. When the ship tilts, the stability of the ship depends on the distance between the center of gravity and the metacenter, which is called metacentric height. The higher the metacentric height, the greater the stability of the ship, so rescue ships must calculate the stability of the ship both at sea and in port to prevent the ship from capsizing or sinking. These are some of the aspects you should know about the anti-heeling system and rescue ships, which are systems and ships that contribute to saving lives and protecting the environment. Can you imagine a ship flipping completely and then returning to its normal position? This is possible thanks to rescue ships with the concept of 180-degree vessels. These rescue ships are an innovative solution to face the challenge of extreme weather conditions and high waves at sea, which can hinder search and rescue operations and cause ships to sink. In addition to being able to self-right, self-righting ships can operate in extreme maritime conditions. Several companies manufacture these self-righting ships, one of which is the Royal National Lifeboat Institution, RNLI, located in the United Kingdom. Creating these self-righting ships requires several essential elements that allow them to return to their original position by themselves. How is it possible for a rescue ship to return to its normal position after completely capsizing? The answer lies in several elements that make this engineering miracle possible. The first is the initial design of the ship, where all equipment and heavy objects must be placed as low as possible within the ship. The second is the operation and control area of the crew, which must be lightweight, sturdy, and filled with air. Additionally, the crew access door must be watertight to prevent water from entering the space when the ship capsizes. In self-righting ships, when the self-righting ship capsizes, the weights of the pendulum system are hung vertically, causing all open sections to close automatically and preventing water from entering the ship. These self-righting ships have an onboard system that detects if the ship is capsized. This system automatically protects the ship by shutting down the radar and engines before straightening the ship to its original position. Once the ship returns to its normal position, the radar and engines are restarted. Furthermore, crew members inside the ship must be seated and secured with seat belts to ensure their safety during a capsizing event.